Find the derivative of y equals the root of x. And of course, that's just f of x. And we're going to be using the definition of the derivative. So without further ado, let's get started. Lim as h approaches 0 of f of x plus h. F of x plus h in this case is just going to be x plus h, because we are just replacing the x plus h for the x, for the f of x function. And we're going to subtract f of x, which is just the root of x, and we have that all over h. How can we simplify this and get further with this expression? Well, we're going to have to multiply the top and the bottom of the fraction by the conjugate radical. And the conjugate radical will be just exactly what we have here, but with the signal switched. So it's going to be a plus instead of a minus. So we have x plus h plus the root of x, or rather the root of x plus h plus the root of x, all over the same thing, of course. Otherwise we would be changing the equation. Great. And why did we do that? Because once we expand these guys and we multiply them, we are going to be basically getting rid of the radicals. We're going to be getting x plus h minus x. And why is that? I think I have room to do it here. I'm just going to quickly expand it to show everyone. Oops. There should be a minus. Okay, we would be foiling this, of course. The root of x plus h times the root of x plus h is just x plus h, because the roots are going to cancel out. Root of x plus h times the root of x is just the root of x times x plus h. Then negative root x times the root of x plus h will be just minus root of x times x plus h. Then negative root x times root x is just negative x. Now, these elements here, this guy and that one, are going to cancel out, because the root of x times x plus h minus the root of x times x plus h is just going to be 0. Then x plus h minus x is just h. X plus h minus x is just h, of course. Then at the bottom of the fraction here is going to look like h bracket x plus root of x plus h plus the root of x bracket. And right away we can actually cancel out these h's. And why is that? Because the x's are gone. So these h's get canceled out, and we end up just with a 1 here on top of in the numerator of the equation. I always just say the top of the fraction, but it's the numerator. So lim as h approaches 0 of 1 over the root of x plus h plus the root of x. At this point, of course, we can just get rid of the limit, plug in 0 for h, and we're going to end up with 1 over x plus 0. Well, that was messy. Plus the root of x. The root of x plus 0 is just the root of x, and root of x plus root of x is just 2 root x. And this is the derivative of y equals root of x. I could rewrite it as 1 over 2 as x to the negative half, but it's up to you guys, really, the way you want to show this. And that's it.